Morning. The weather outside is lousy, so what better to do than to get on with some more working on the teleprinter. We've ordered a bunch of parts to build a new power supply based on what we learned last time. Those parts haven't arrived yet, so we are probably going to park the power supply side of things today and instead have a look at the wiring. And so Paul and I are hoping to work out what the wiring is. Let me see if I can find the cable. That's the power, that one's the power cable, and then this one is the data cable. So as you can see, if I get it against a nice white background, it's just a bunch of wires, but although they are awesome kind of cotton braided goodness, they're cool wires. When I stripped this one a couple of weeks ago, we're going to work out which wire's which, and then probably hook it up to an Arduino, start seeing if we can work out how to decipher what it's doing. So that's today's plan.
So for the two cables coming from the teleprinter are the power cable and the data cable, or we call it the data cable, more like a control signals. The immediate difference is that this one, the power cable, is rubber, or it's some kind of plastic. It's already got a terminal block on the end. And this control cable, these are all individually braided and tricky to strip. Of course, you can't just put these into a regular stripper, so they were cut individually with a little Stanley blade or a scalpel, if we had one of them. And one of them has an outer shield braid, and within the braid are 3 extra layers beneath that outer braid. There is a wrapped around cotton braid. Then there's the crusty layer that just crumbles off, whatever it originally was, I don't know. Then there's another wrapped cotton layer, and that comes off, but it's quite fiddly to get off, but there it is.
Yeah.
So
full set and
little collection of individual color braids that came off by kind of rotating each wire and cutting it kind of like that.
Awesome. And then missing the stripy one because I didn't save that bit when I stripped that one last time, so we don't have a nice, that'll be the rubbish stripped one, and like all the nice neat work that Paul's done,
and the white one as well. I don't know where that.
Okay. Yeah.
So that's the that's the cable
all stripped.
Right.
And then whilst Paul has been doing that, I've been looking at wiring diagrams to try and work out where those wires go. So there was this, in this teleprinter handbook that we've got, it has this wiring it has 2 wiring diagrams, one for a 12-pin plug and one for a 9-pin plug, and we've got 9 wires. Obviously we don't have a plug on ours, so you'd think maybe it's this one, which it might be. We haven't worked out yet, but I've also been looking at this PDF, which I don't know why we didn't pay more attention to this in the past, because this is a manual for overhaul and repair of a Creed 7B, which has got loads of really good stuff in it, including, actually, I'll skip down in a second to the bit at the end. But yeah, this one has a 9-pin plug and has all of the colours on this one, which is good, and the colours match all of the colours that we've got in our control cable. And I especially like this slate rather than grey. We should totally call wiring, it should be slate rather than grey. That's cool. So I've been having a look through what these, tracing through where these different ones go to. It's super interesting how they always change colour. almost. Like the blue one is still blue when it comes through this terminal block, but like everything else, you know, the black one becomes white, of course, and you find that black is the new orange, or orange is the new black, depending on which way you're going through the terminal block. So yeah, I've been kind of tracing where these ones go, and then we can hopefully work out whether this diagram or this diagram is the correct one in a bit, because they don't match. But yeah, and then the one other thing, just whilst we're here, if I skip down to the end of this manual, you get this cool list of like tools that you might want. Yeah, list of teleprinter tools, etc. With like the stores reference. So yeah, we obviously need to work out where we can find a 1H21 spanner flat number 1, or maybe we'll want a capstan spike number 3B. So yeah, this is like quite nice. I don't think we've got all of these tools, but hopefully we've got enough to be getting on with. And now that we've got all of the wires stripped, then the next step will be to work out which of these wiring diagrams is correct, and then start to work out how we wire it up to like probably an Arduino, so that we can start to measure some of the, you know, marks and signals, so when we hit a key, it will kind of cycle through. Yeah, we'll be running it by hand at the moment because we don't have a power supply, so we're probably not going to get like a full decoding thing, but we can, yeah, see where we get to, and hopefully get a start made on some of this, so that once we've got a power supply, we'll have the beginnings of circuitry and code to try and decode what we're getting. So that's the next step. So we think we have it wired up to act as basically as a typewriter. So reading through, let me just show you, through this book, there is a circuit, and it's this bottom circuit that we're using because we've got a creed which is double current, so it basically goes between plus and minus 80 volts. And it's not the easiest kind of circuit to follow, but basically, yeah, these pins are on the 12 pin plug. We've got a 9 pin one. We've worked out what that is, but basically you've got 80 plus and minus 80 volts going into mark and space. The keyboard will then flip between them to provide an output, and so this 2 going to 9 is basically a little loopback. So it will take the thing that gets transmitted by the keyboard, which is kind of this bottom bit, and feed it into the electromagnet at the top, which will make the electromagnet go one way or the other way, to then do the marks and spaces. And so yeah, this is the electromagnet that will flick from side to side to make the receiver section select the correct character. The keyboard will do the marks and spaces, which that kind of mark and space switch is one of the contacts in here. But that's all connected through this data cable, which we've crimped lots of nice connectors on so that we can wire it all up to things. We've got a double bench power supply running at kind of each one at 15 volts. They're then tied together so that we end up with kind of minus 15 volts on one side, plus 15 volts on the other side, and a common ground. So that's wired down. So let me see, yeah, that one is the common ground, which is the red, which is going to one side of the electromagnet. The white is going to the other side of the electromagnet, which is what's kind of fed in the, like this wire here, this super short one. It conveniently was just long enough when we'd, I should cut longer bits of wire sometimes. But that's the loop back, which is basically the, this one and this one. those are the plus and minus 80 volts, as it were. That's 15 volts in this case, but that seems to be enough, which go onto the orange and the brown and the green, and the blue is the signal that comes back from the keyboard. That gets looped back through the electromagnet. So now, moment of truth. So we can turn the power all on, and Paul is going to type something whilst Mike pretends to be a motor. And we will see whether we get the correct output from the keyboard and see if it works. Like we're
running at about 400 milliamps.
400 milliamps through it. Okay. How's that?
A bit high, isn't it? Because
Yeah.
round out the current limits.
Okay.
Because they're missing a couple of resistors, I suspect.
Yeah. So you just take the current limits down a bit to use the current limits on the, yeah, basically using the circuit here has a little filter. We haven't built the filter and the little meter output stuff and the variable resistor to dial things down. We should run it at about 20 or 30 milliamps. So Mike is just tweaking the current limiting on the power supply to get us to those sorts of amounts.
Down to about 5 volts on the current limit.
Right.
So one of them.
I guess one of them's not in circuit at the moment, is it? One's like, because it will be sat in mark at the moment, won't it, by default?
Yeah.
So at idle, the circuit sits at mark. So the space circuit won't be drawing any current
so
yet.
The plus voltage is drawing voltage current at the moment.
Right.
Which is right. Which is space is plus 80 volts.
Space is plus 80 volts. Yeah.
And mark is minus 8, isn't it?
Yeah.
So we
should, yeah, let's give it a go. So I'm trying to work out what the best way of showing this is going to be. But as Mike shows at the moment, that when the motor runs, nothing's happening because there's nothing being transmitted. And then if Paul types one of the keys, we see that it's flicked, and now it's going through, and it's picked marks and spaces on these 5 triggers here, and it'll strike that key when the next key is pressed. But that should also go back, and we should see space mark, space mark.
it releases the key after a certain.
Is that correct? Space mark, space mark, space, or have we got? Let's jump. We jump back in to another part of the thing, and we can look at the letter R, which should be space mark, space mark, space, which is what we had. And if we type a letter Y, we should get mark, space, mark, space, mark. So let's back over to the thing, and Paul is going to do a Y, and we should then see that do space mark, mark, space, mark, mark, space, mark, space, mark. Yeah. Well, hey, excellent. It's doing the right thing. It works.
So we found a bug in the wiring. One of the wires previously connected or looped back the white to the blue. I think it was.
No, that bit's fine, and we should do that. It was.
Right.
It's the fact that this orange wire and this brown wire are quite similar colours.
Right. Okay.
And so we'd accidentally wired the space, like the positive voltage, yeah, should go to the orange wire, as it does now. And before it went to the brown wire.
Which meant it went to some electromagnet somewhere.
Yeah, the brown's got some weird connection to the electromagnet that I don't fully understand.
Yeah.
But
Yeah.
yes, yeah, I'm sure we can work it out at some point. But yeah, at the moment it's doing weird things.
So now it's been rearranged, and the LEDs light accordingly to marking space. We can spin the wheel and press a key.
And we can also see the current that's flowing, so that's in the circuit. So I guess, yeah, the LEDs are just wired in opposite directions, so that when the current is flowing one way, we get one LED lit up, which will be a mark, and then when the current's flowing the other way, we get the other LED lit up, which will be a space.
Should we try that?
So we should, yeah, do you want to try typing something, Paul, and we can see?
Spin. Press Y. That was Y.
So that was a Y.
And press R.
And R. So yeah, the R and Y are nice ones because they just go mark space, or space mark. Yeah.
I think I noticed the first bit after the start bit was the same as the start bit on the R. Yes, it is.
Excellent. Paul checking with the diagram to see that we're getting things the right way around. So yeah, this is like first step towards working out how we're going to wire some circuitry in to be able to connect this to some sort of Arduino microcontroller type thing, and see what we're receiving.